So now let us do one more application based on distance formula, and which is the property of rhombus now. If P 2 minus 1, Q 3 4 and R minus 2 3 and S minus 3 minus 2 be 4 points in a plane, show that PQRS is a rhombus but not a square, and find out the area of rhombus. So we need to show that those 2 points are the vertices of rhombus. Now before doing this problem, let us recall the properties of rhombus. How to show the rhombus? Show it as a rhombus. We need to know the properties of rhombus from the plane figures, plane geometry. I am telling you once again, I am telling you that this plane geometric applications are very important to solve each and every application in coordinate geometry. That's for sure. Okay, anyways, so now let us recall the properties of a rhombus from the plane geometry. If you take a rhombus, okay, in rhombus what are the properties? Okay, properties of rhombus are, let us suppose here A, B, C and D are the vertices of rhombus. Okay, then what about the properties of sides of a rhombus? Here opposite sides are parallel. Okay, leave it. All the sides will be equal. So first of all we need to know that all the sides of rhombus are equal. Okay, all the sides of rhombus are equal. First point about the sides. Now even there is a confusion between rhombus and a square. Okay, even in square also all the sides are equal now. So it is not sufficient to show that only 4 sides are equal. Other than that we need to show something else. Understood? So here in the property of diagonals, square will differentiate, rhombus will differentiate from square. Understood? So now in case of sides we can't say. Even 4 sides are equal, then it can be a rhombus or it can be a square. But when coming to diagonals, okay, there is a little bit difference between diagonals. In square diagonals are equal, but in rhombus diagonals are unequal. Understood? So we can say that what are the major properties of rhombus regarding its sides and diagonals? Here all the sides are equal. AB equal to BC equal to CD equal to AD. All the sides AB, BC, CD, AD all are equal, and diagonals shouldn't be equal here. Okay, diagonals are perpendicular bisectors of each other of course, but lengths of the diagonals are unequal. Understood? So therefore this diagonal AC will never be equal to BD in case of rhombus. So these properties are sufficient to show. What we have to show to prove it as a rhombus, we need to prove that all the sides are equal and diagonals are unequal. So these things are enough to prove that these are the vertices of rhombus. Given that, let me write here answer. We have given here PQ, PQRS are the 4 points. Okay. Now we need to show that all the sides are equal or not. We need to check whether all the sides are equal or not. So find out each and every side, length of each and every side. That means here we need to find out the distances between every 2 points, PQ, QR, RS and PS. Got it? So now let us find out PS first. Okay, first find PQ, distance between these 2 points. PQ means here this 2 is x1, minus 1 is x2, y1, and 3 is x2 and 4 is y2. Understood? So now if you want to find out the distance between them, put them in the formula x2 minus x1 whole square plus y2 minus y1 whole square under square root. So under square root x2 minus x1, which is 3 minus 2, 3 minus 2 whole square plus y2 minus y1 whole square. This is 4 minus of minus 1. So 4 minus of minus 1 whole square. Okay, this is what the value of PQ. So now tell me what is PQ here. PQ equal to, simplify this, 3 minus 2 would be 1 square. Now 4 minus of minus 1, that would be 4 plus 1, that is 5 square. Okay, now how much it would be? So this is your 1 square is 1 itself and 5 square is 25. The total would be root 26 units. Root 26 units. So we find length of PQ or distance between P and Q, which is side PQ. Understood? Now let us find out the side QR. Okay, let me find it here. QR equal to what? Distance between the points Q and R. See, this is x2 minus x1 whole square. What is x2 minus x1 whole square? Minus 2 minus 3. Minus 2 minus 3 whole square. Okay, and 3 y2 minus y1 whole square. This is 3 minus 4 whole square plus 3 minus 4 whole square. Okay, now tell me here, this is minus 5 or not? Okay, this is minus 5 whole square, and this is 3 minus 4 would be minus 1 whole square. Since there is a square in the power, whenever we are getting power, even number in the power of negative basis, the resulting number would be positive. Okay, so that means a result of either minus 5 square or plus 5 square would be same. That is your 25, right? So here the minus 5 square value would be 25 and minus 1 square value would be 1 itself. So again we obtained root of 26 units. Okay. After finding QR, okay, we find here first PQ, then QR, and now distance between RS we need to find. Okay, let us find it out. RS. RS equal to what? Distance between the points R and S. So here x1 y1 and x2 y2. So what is the formula? x2 minus x1 whole square plus y2 minus y1 whole square. Okay, x2 minus x1 whole square would be minus 3 minus of minus 2. So minus 3 minus of minus 2 whole square. Okay, this is minus 3 minus of minus 2 whole square. Now minus y2 minus y1, minus 2 minus 3. So now this would be minus 2, okay, plus minus 2 minus 3 whole square. Okay, now what it would be? Just see, this is minus 3, minus of minus 2 would be plus 2. Minus 3 plus 2 would be minus 1 whole square. And this would be how much? Minus 2 minus 3, that would be minus 5 whole square. And as I said you before that, if power is even number, even for negative basis also we'll get the resulting number positive. Okay, here minus 1 square would be 1 itself, and minus 5 square is also 25. What is the value? Root 26 units. Okay, now let me write, let me find out. See, what did we find till now? We find PQ, we find QR and RS. Now let us find out the distance between PS. Okay, now distance between P and S we need to find. Okay, PS, what is PS here? PS equal to here, let us consider this minus 3 minus 2 as x1 and x1 y1, and this would be your x2 y2, or else this is x1 y1 and x2 y2, any order you can select. Okay, now the formula for this would be x2 minus x1 whole square. What is x2 minus x1 whole square? Minus 3 minus 2 whole square. Minus 3 minus 2 whole square. This is minus 3 minus 2 whole square plus minus 2 minus of minus 1. Minus 2 minus of minus 1 for this whole square. Okay, now let us write down. Minus 3 minus 2 would be what? Minus 5 for this square. Now minus 2 minus of minus 1 would be plus 1. Minus 2 plus 1 would be minus 1 whole square. Since there is a square in the exponent value, means power value, so negative base also will provide you, will result you the positive number. Understood? So here minus 5 square or 5 square will be 25 only. Here this also 1. So this is again how much? Root 26 units. Let me tell you this, guys. Here already we said, see, let me tell you, this is some PQ, QR and RS. Okay. Now let me take here, this are PQRS. Okay. What did we obtain here? Tell me. all are 25, all are root 26s only, no? So what is the value of PQ here? Root 26, and value of QR is also root 26, value of RS is also root 26, and value of PS we find it as root 26. That means all the sides we got equal values. PQ root 26 we obtained, QR root 26 we obtained, RS we obtained root 26, and PS we obtained root 26. So all the sides we obtained equal. So that means here PQ equal to QR equal to RS equal to PS. Got it or not? PQ, QR, RS, PS or SP. So this is the first property we have shown. Okay, it's over. That means we have shown now all the sides are equal. So here when all the sides are equal, there is a possibility for two figures. One is square and one is rhombus. Now we need to prove something about diagonals. Now let us find out the lengths of diagonals. Now tell me, what is diagonal here? Tell me. Here PQRS, diagonal means the line joining opposite vertices. Here this P and R, that is PR. This is one diagonal, and QS is another diagonal. Let us find out the length of the diagonal PR first. Okay, now let us find out PR, distance between P and R. Okay, now what is P, which is P and which is R? This is P and this is R. We need to find out the length of this diagonal, means distance between these 2 points. So let us find it out. What is the formula? Under square root x2 minus x1 whole square plus y2 minus y1 whole square. So see this here, this is x1 y1 P and this is x2 y2 R. Okay, now what is formula? x2 minus x1 whole square means minus 2 whole square, minus 2 whole square plus y2 minus y1 whole square, minus 3 minus of minus 1, minus 3 minus of minus 1 whole square. Right? See, minus 2 whole square, this is not minus 3 plus 3, sorry, 3 minus of minus 1 whole square. I am sorry to say this is not minus 3, I have forgotten. See this is 3 minus of minus 1 whole square, which is PR. Okay, distance between this and this. Okay, let me tell you. So simplify this further. Okay, now minus 2 and minus 2 added together to obtain minus 4 square. Now 3 minus of minus 1, that would be your 3 plus 1, that would be your 4 square. Now tell me guys, here either minus 4 square value or 4 square value would be same or not, because here power is even number 2, power is 2, so even minus 4 base also will provide you same answer as plus 4 square. Understood? So how much is this value? Tell me, this is 4 minus 4 square would be minus 4 into minus 4 plus 16, and this also would be plus 16. Got it? How much is the value here? This would be 16 plus 16, which is 32 units. Okay, 32 units. Now we find the length of one diagonal. Now let us find out the length of another diagonal, which is QS. Got it or not? We find length of first diagonal, which is PR, and now let us find out another length of the diagonal, which is QS. Let me find it out. QS. What is the length of QS? The QS is the distance between the points Q and S. See, this is Q. Let me underline, highlight here. So this is and this is. Okay. Distance between those 2 points we need to find out here. Okay. What is the distance between these 2 points again? X2 minus x1 whole square. What is that x2 minus x1 whole square? Minus 3. Okay. Minus 3 whole square plus here this is minus 2, y2 minus y1, minus 2 minus 4. Okay, minus 4 whole square. Okay, so now let us simplify it further. Minus 3 added together and we'll get minus 6 whole square. And this is minus 2 minus 4 added together to get minus 6 whole square again. Okay. Now let me tell you, Here minus 6 whole square or plus 6 whole square will give you the same value, positive value, because power is even number. Okay, minus 6 whole square would be plus 36 and this is also plus 36. So we can write this as 36 plus 36. Okay, now this would be how much? Under square root 72, or else we can say 6 root 2 also. Okay, so whatever, here this is. Now tell me what the value of PR we obtained. PR value of PR would be your 32 units and value of QS is your 72 units. You obtained or not? Now tell me what are PR and what are the PR and QS lines? Here PR represents one of the diagonal of this quadrilateral and now QS is another diagonal of this quadrilateral. So we obtained this value as root 32 and this is root 72. Tell me, are they equal? No. So these are not certainly equal. So here PR is unequal, means not equal to QS. Okay. Now we obtained two properties. One is all the sides are equal, but we got diagonals unequal. So now it's a rhombus, because for rhombus all the sides are equal and diagonals are unequal. Got it? All the sides are equal, but two diagonals are unequal. If it has to be a square, then this diagonals would be equal. Understood? Diagonals should be equal for a square. What we need to show here? We need to show that these are the vertices of rhombus. This forms a rhombus but not a square. When it can be a square? If PR is equal to QS, then it would have been a square. Okay, but PR is not equal to QS, no, then it is not a square. See, there is a common property for square and rhombus is all the sides equal. In rhombus also it happens same and in square also it happens same. For both rhombus and square, all the sides are equal. It differentiates in angles and diagonals properties. Coming to square, both the diagonals are equal. Means here in case of this diagram, PR should be equal to QS. Then it would be square. But here QR is not equal to QS is not equal to PR. Okay, PR is not equal to QS. We obtained. So there is only one property which differentiates from square to rhombus is, okay, in square diagonals, lengths of the two diagonals are same or equal, and in rhombus diagonals are unequal. So we proved it unequal, so hence it is a rhombus. Okay, so these are the points which can be the vertices of a rhombus. Got it or not? Anyways, now we find this. Now we are asked to find one more thing here. We need to find out the area of. Okay, we need to find out the area of rhombus also in this figure. How to find out the area? Yes, I think we need we have done this in areas and volumes topic. Okay, what is the formula for finding the area of rhombus? Half into d1 into d2 or not? Area of the rhombus depends on the lengths of the diagonals. When diagonal 1 and diagonal 2 are given, then we can say that area of rhombus would be, see here, area equal to half into d1 into d2. Understood? What is d1 here? Half into d1 would be here PR, first diagonal, into QS, second diagonal. Now what would be that? Half into PQ value. PR value already we find it out. How much is that? Root 32. Okay, so this is root 32 into, now this is root 72. Okay, let me simplify this further. Okay, see this 32 can be splitted into what? See, let me write this part here. I will write it here. Okay, this step I will continue here. Okay, now tell me, how can we split this root 32? Root 32 can be written as 16 into 2 or not. Now we can pull this 16 out. When you pull this 16 outside, okay, then 16 square root of 16 would be 4. Understood? So this would be your 4 will be when 16 comes out and becomes 4, and root 2 will be left over. Understood? 32 can be written like this. And what is 72? 36 into 2, no? 72 can be written as what? Root 72 can be split into root 36 into 2. Again this 36 can be pulled out. So it becomes 6, because square root of 36 would be 6 only, and 6 root 2. So we find here the value of this would be 1 by 2 into root 32 value was how much? Root 36 value of PR would be 4 root 2. 4 root 2. Value of QS would be 6 root 2. This 72. Understood or not? This 32 can be written as, rewritten as 4 root 2, and this root 72 can be rewritten as what? 6 root 2, right? So like this we can do this. Okay, now we can cut this 2 with the 2 2s are 4. Okay, now what is left over? Just let me simplify this. Almost last step of the problem. Okay, just look at this. Now see, here we cut down this 2 with 2 2s are 4. What are left over here? 2 into 6. 2 into 6 into here root 2 into root 2. Root 2 into root 2. Once again I am showing you here. This is 2 2s are 4, no? So this is 2 2s are 4, here 2 is there, and here 6 is there, here root 2, here root 2, I wrote all of them, and I want to take the product of this. Now this tell me, 2 into 6 would be 12, root 2 into root 2 would be root 2 square, and square and square root will be cancelled. Now 12 into 2, that would be 24 square units. Understood? So like this we can find out. So this is simplified value of this. Understood? Like this we can find out area of the rhombus also. And here we need to notice how many things here. See, we are here we just know the distance formula from this coordinate geometry. Other than that, remaining all the properties which we are taking here are pulled from where? From the plane geometry and mensuration only. Understood? If you want to show these vertices points are the vertices of rhombus, you certainly have to know that the rhombus properties, that all the sides should be equal and diagonals should be unequal. That is first geometric property we need to know to show these points as vertices of rhombus. And second thing, anyways we have shown that. Now you are asked to find out the area of rhombus. Then you need to go for mensuration, areas and volumes. You need to have the awareness on the formulas. What is that? Area of the rhombus depends upon lengths of its diagonals. So lengths of diagonals would be d1 and d2, then half into d1 d2, where here lengths of diagonals are PR and QS. Then we put down the values of that and we simplified these surds into some mixed surd format, and we cancelled this 4 by 2, 2, 6, root 2, root 2 we obtained and simplified to get 24 square units as your answer. So see this guys, I am telling you once again, so many times I am repeating that plane geometric applications are very much important for solving all the problems from coordinate geometry, unless you can't solve it. Anyways guys, so I hope you would have enjoyed this video. My videos are a bit lengthy but quite informative. Understood? I want to teach you everything very slowly and very informative manner. If you are not understanding anything or if you are expecting anything else from us, please don't forget to put in your comments. Okay? So anyways, for today this is it.